I got the slides. We have 2 microphones for some reason, so that's good. Make sure this is on so we don't have issues. Sound check. All right. Oh, here's the. I don't know if that works.
All right, but you're going to drive the slides, or you've got the slides? Okay.
I've got the slides, but I.
Yep.
Maybe I need to plug in. Is there a? Oh, here's the. That's what it is. Let me see if I can get it.
Is that your computer, or do you want to do it on this one?
I think we have to do
Right.
it on this.
Okay.
I think that's only for Meet Echo.
Okay.
Yeah, it's not looking good, so we'll just ask people to.
Okay, next slide.
Yeah. Anyway, we can get started whenever.
Yep. All right, I think we're ready to get started.
We don't hear you.
Do you not hear me?
I can ask Meet Echo to turn it up.
All right. Mike for breakfast. All right, so if we can get started, we are your chairs. I'm Leslie, he's Kyle for the Media Operations Working Group. And as noted on the slide, this session is being recorded. Next slide. I hope you have all noted well. This is Monday morning, first official session of the day of the week, and make sure that you note well that you are participating in the IETF and agreeing to abide by its processes and policies. If you have any IPR, make sure that you disclose it in the appropriate fashion, and acknowledge that any written audio, video, and photographic records of meetings may be made public. That includes this meeting.
This meeting is also being filmed.
Really? On film? Film?
Video.
All right. Yeah, so there's plenty of reference documents if you would like to read more about the various and pertaining policies. Next slide, please. Yes, and we are going to be using the Meet Echo queue to run all of the queue, so please make sure you join Meet Echo either in the in-room tool or on the full tool as you like. And if you have a question, please join the Meet Echo mic queue. As Kyle said, if he has to wear a mask, we all have to wear masks, so we're all wearing masks, unless you're actually actively presenting or eating and drinking. Okay, and then additionally, when you're joining, please do make sure your audio is off, unless you're actually in the queue and speaking. All right, next slide, please. Yeah, we have the agenda and all the other information available, but I think this is not new news. Thank you. Next slide. Here's the agenda for today. Do we in fact have a minutes taker volunteer? It is so much Monday. I see a lot of heads studiously staying ducked down.
Mike, you guys should be enthusiastic. It's the first session.
Sorry, was that a volunteer? No?
No. As I said, I was like, no.
We need one.
Yes, we
If don't get a
do.
volunteer, we're gonna have to turn this car right around and go home. So.
Fine.
Thank You.
That's right. That's what I agreed to.
Yeah. But please, everybody, do join in and help out, fill in any blanks as necessary. Yes. Any other bashes to the agenda? Not hearing any. We'll move right along into working group documents. So, Rhiannon, if you would please come join us. And nice to see you in person.
Yeah, nice to see you.
Yes.
Nice to see everyone.
So just let me know when you want me to advance to the next slide. The
Yeah.
clicker's not working. So.
Okay, hi everyone. My name is Renan Krishna, and I'll be presenting an update to our draft. This is joint work with Akbar Rahman. Next slide, please.
Or grab the mic. And
You want to
Check.
Yeah, you can. But stay on the pink thing so that you stay in video.
Oh, okay.
Yeah.
So for this particular update, we have changed sections or updated sections 3.1 and 5.1, and we'll describe what we have done in those sections in the next few slides. Next slide, please. So thanks to Cullen Jennings, we have elaborated the techniques to acquire a model of the real world, and this is in section 3.1. So we already had an annotated point cloud-based model description. We have added a couple of lines for polygon mesh and texture mapping techniques. And we have added a model based on light field, which is in data structure terms a table called environment map that describes the intensity or color of the light rays arriving at a single point from arbitrary directions. So a couple of lines each for all of those three models. Next slide, please. In section 5.1, we have elaborated the AR traffic workload characteristics that the operators will have to support in use cases such as ours. So in particular, if we imagine multiple AR devices connecting to edge server, each of the traffic being generated by each of the AR device is actually heavy-tailed. And if you aggregate heavy-tailed traffic, what you'll find is what is known as long-range dependent traffic with two particular characteristics. The first is the parameters of the traffic, such as volume of XR data, burst time, idle time. They could be widely separated in time, but show correlation. And also you'd find long bursts of traffic. So the operators should be able to provision edge servers so that they can manage the long bursts in traffic. Next slide, please. So really this slide should have been titled Next Steps. So in the previous IETF, we the working group had suggested us to present some numbers. So we have dug into some of the publicly available data. And so here is a list of throughputs for certain types of applications. So for example, for image and workflow downloading, you'd have 1 Mbps, and we have given the reference there. For video conferencing, we'd need a capacity of 2 Mbps. For 3D model and data visualization, we'll need 2 to 20 Mbps. For two-way telepresence, we'd need 5 to 25 Mbps. For current generation 360 video, typically 4K, you'd need 10 to 50 Mbps. For next generation 360 degree video, and that should read 8K, not BK, sorry about that. And 90 plus frames per second, HDR and stereoscopic, with stereoscopic coming for both the eyes. You'd need typically 50 to 200 Mbps per second. And finally, for 6 degree of freedom video or point cloud, you'd need 200 to 1,000 Mbps. So these are some of the throughput numbers that we have found in reference 1. Next slide, please. And here is another set of numbers. Here we have included the expected end-to-end latency values as well. And we have a set of applications arranged in taxonomy. So the first one is AR-based remote surgery with uncompressed 4K 120 frames per second, HDR 10-bit real-time video stream. So for this, the expected end-to-end latency is around 750 microseconds. The expected data capacity is 30 Gbps, and possible implementation examples are, this is basically a newspaper article which claims to be the world's first remote surgery over 5G. Then the second application is mobile AR-based remote assistance with uncompressed 4K 120 FPS, HDR 10-bit real-time video stream. The expected end-to-end latency is less than 10 milliseconds. The expected data capacity is 7.5 Gbps, and possible implementations or examples are assisting maintenance technicians. So these are essentially helping in the workflow. Then Industry 4.0 remote maintenance, remote assistance in robotics industry with those references. Then the third application is indoor and localized outdoor navigation. And in this taxonomy from reference 2, our particular AR use case fits in that category. So the expected end-to-end latency is less than 20 milliseconds. The expected data capacity is 50 to 200 Mbps. And possible implementation examples are theme parks, shopping malls, archaeological sites, and museum guidance. And finally, for cloud-based mobile AR applications, the expected end-to-end latency is less than 50 milliseconds. The expected data capacity is 50 to 100 megabits per second, and you have a couple of possible implementation examples there. So one thing we wanted to point out for our use case is that our use case is obviously for a mobile AR scenario, and that it specifically deals with a scenario where you have tourists moving in an outdoor location. And outdoor locations are typically very challenging for most of the techniques because the light conditions change continuously. The angle at which the tourist is looking at the scene changes continuously. And there might be people moving in and out of the AR field view. So our particular use case tries to showcase the problems inherent in an outdoor mobile AR system. So with Chair's permission now, I'd like to invite comments and discussion. Does the working group like these numbers? Is it okay for us to write up these numbers in the actual draft? Because this slide and the previous slide, the numbers shown there have not yet been included in the internet draft because we wanted to have a discussion at this IETF. So comments, suggestions are welcome.
And please use the Medico queue.
Hello. Hey, Hang Shi from Huawei. For this end-to-end latency, you mean the one-way delay or the round trip time?
Yes. But
So
yes, this is round trip time, yes.
So you are assuming the application is interactive, right?
Say that again?
You are assuming the application is interactive.
Yes.
Okay. And this 30 gigabits per second, the number seems too huge, right?
Absolutely. I think one of the questions which I had after seeing this reference was, is it common practice to send uncompressed 4K videos? Or do we need to send a compressed 4K video? Because if you send uncompressed 4K, you would get a high data capacity requirement.
Yeah, I think the problem is your end-to-end latency is too tight, maybe for the compression. The compression computing time is maybe bigger than this one.
And I note that there are more people in the mic line than there are in the online line. So if you could use your phones while you're in the mic line to actually get in queue. Next in queue is Sam Hurst.
Hi there, Sam Hurst, BBC R&D. Just a point on the uncompressed. Have you considered maybe doing something like an iframe only, very low latency encode that's going to have much higher quality and will be realistically as close as uncompressed could possibly be to the human perception?
Sorry, could you repeat that? I couldn't hear that.
Yeah,
We're gonna raise the mic. Just give it a
Thanks very
second.
much. I'll leave it on there. Yeah, it's just instead of using completely uncompressed, to be considered a really low latency iframe only compression, which is to the human visual system, will be as close as uncompressed and would probably save you quite a lot of that data capacity.
Yeah, absolutely. And I think so. So this is from someone else's work. This is not our work. And what we really want to do is to capture the current industry practice in this document. And the goal really is to have some operator going out and deploying in the field something like our use case. And definitely I'd welcome your comments on the draft at GitHub if you feel that that's an important thing that needs to be mentioned in the draft.
Well,
So,
thanks very much.
Thanks.
All right, and the chair recognizes himself. It seems to me like if you're going to put numbers in at all, they're kind of a moment in time, and they need to be from the same moment in time, right? I mean, uncompressed video, right, obviously is not going to change bitrate ever for the same resolution, but compressed video will over time. So are these numbers all from kind of a similar generation of technology for video compression? That would be the important part. And to make it clear in the draft, I note that I haven't read it since you made the changes. Does the draft make it clear that this is from a moment in time, and put it in that context?
Absolutely. So this is from reference 2. So so all the references from there are roughly in the 2017, 2018, 2020 timeframe. And I agree that we should specify the time frame for the numbers there, because they will of course keep changing.
Spencer?
Spencer Dawkins, and I congratulate you for having numbers. And my suggestion, I think, for the working group is for us to think in terms of rough orders of magnitude, clumps, rather than, talk about whether something is less than 20 milliseconds or less than 30 milliseconds. We spend awful lot of time having similar conversations on streaming media in the draft that was just published as an RFC. And if I had one thing to do over again, I think that would be, like I said, moving towards ranges and kind of having that focus. This gives us something to shoot at, and if somebody accidentally comes up with a way to compress light ray, that'll be awesome. And kind of not be surprised if we don't find things to do with the bandwidth. It's like, well, if it's not 7.5 gigabits, it will be something much, something very large. So taking what Kyle said about, going with the, one generation of numbers, and then thinking in terms of ranges, I think that's the best advice I could give to the working group about this draft. Thank you.
Thanks. A couple of other issues. So
Yeah, there are actually still a couple of people in queue. Do
Okay.
you want to still?
yeah.
Yeah, okay. All right, Giles next.
Thanks. Hopefully I'm on audio now. Yeah, I think for the first number, I guess I would say I get kind of nervous whenever I see numbers below 1 millisecond where humans are involved, particularly given our perception, and particularly if you look at that being 120 frames per second for the first example, you're never going to get the video latency down below 8 milliseconds on that basis. So, you know, really those kind of endpoint latency figures are pointless at that stage.
Any follow-up, or you just want to take that on board?
Say that again?
Any follow-up, or do you just want to
Yeah.
take that comment on
So,
board?
so the other issue was, a couple of IETFs ago, someone mentioned that besides Edge, we could look at other architectures, but we have argued in the in the draft that Edge servers are necessary for latency reasons. You need to place the computation close to the user. So one question I had was, are there other architectures which do not use that paradigm?
Other architectures in particular for
For
AR?
For offloading
Right.
AR computation.
Anyone? Anyone? Doesn't look like anyone has any concrete follow-up. I think you might want to put a comment in the document to that effect and see if readers of subsequent versions have thoughts.
Yeah. The other issue was that we envisage this running over some form of wireless link, possibly 5G, but Wi-Fi as well. And we'd like the input from the working group of what kind of issues might arise between various kinds of technologies, or is that not an issue at all?
Not a very working group this morning. So I think that these are all important questions, and sort of one of the, maybe we can slide into the where from here part of the discussion around the document. I think that there's sort of three things on my mind. One, I think that those are all important questions, particularly since people have brought them up in previous meetings. It's like, can we get closure on whether or not there are things to follow up here? And if not, drop them. If yes, have concrete suggestions. And then there's the question of, I mean, it seems like it's important to include some level of numbers because it's valuable to have the concreteness. But I mean, following on Spencer's suggestions and other sort of follow-ups, it's probably more important to, you know, have a sense of scale of where this fits with regards to current technologies. So keep it current, as Kyle said, not just in terms of all of these numbers from the same time period, but also compared to what we are, you know, what is realistic to deliver, or where are the challenges in sort of contemporaneous times. And then the final question is, well, and what else? You know, is it just, it sounds to me that like the current action items on this document are the numbers as just discussed. Do a last, you know, set of questions to the working group to see if there's follow-up on the open questions. And, you know, if not, what else? Are we done? Question mark. Do you have any thoughts on what else there would be?
So even for numbers, for example, we'd love to hear from people if they have numbers with regards to traffic characteristics. Because from what we have seen so far, to the best of our knowledge, that kind of work is still not been done. So it would be great to hear from people if they have some numbers to do with traffic characteristics to make things more concrete, really.
Okay, and then there's the question of how do we best follow this up? Because I'm getting the sense that remembering what the questions were at the last meeting and bringing them to the next meeting is not provoking answers. So I think maybe what we can do is sort of pull all these questions out and put them to the mailing list, you know, immediately following this meeting, and try to chase them up. Because I think I'm getting the sense that we're, you know, we may be last calling this document by next meeting. at least for working group last call, and we should use that as a target.
Yep.
Any other thoughts from people on that? Have I scared everybody out of the mic queue? Sorry. Okay. Thank you very much.
Thank you very much.
Are there any more slides?
No, so the next one is the last slide, I think so.
Oh, okay.
Yeah.
Got it.
Yeah.
Thank you.
Great. Thank you. All right, Mr. Dean. Still didn't work.
Oh, yeah, it's still not working.
You're going to run the slides?
Yes.
Okay,
Clicker's not
works for
working.
me. Hi there, I'm Glenn Dean from Comcast NBC Universal. And today I'm going to give an update. One of the things when we created MOPS a couple years ago was to try to connect, the professional media industry, streamers, with work going on at the IETF and vice versa. So one of the things we've been doing ongoing is at SVTA meetings, we give an update on what's going on at the IETF. And at MOPS meetings, we give an update on what's going on at SVTA as a way to connect industry with the Media Ops Working Group. So here's the update for IETF115. Next slide, please. So the first thing I'd like to announce is that SVA has changed its name to the SVTA. It has a T now, because T's are cooler than not having a T in your name. But new name, same mission. We got a T, and we got a new logo that also has a T in it, so it's even cooler than the old logo. And we have a new domain name, which is actually much easier to type. The old one was Streaming Video Technology Alliance, or anyways, now we have just SVTA. Much shorter, easier to type, and life is better. Next slide, please. And for those who haven't heard these updates in the past, SVTA is a industry group. Sorry? Oh, SVTA is an industry group that is focused on the following topics. It's really around streaming, but it's around covering, immersive video, QE, edge storage, players and playback, live streaming, metadata, open caching, networking and transport, a group I actually share over there, and privacy and protection. So it takes stuff from the IETF and other groups, and it actually is professional media people doing this for a living, delivering this environment and putting this stuff to work. And so that's why we have this connection point, because this is what's using output from us here at the IETF and then feeding back insights. Next slide, please. And as an example of the stuff that is actively being used within these groups, one of the things we're doing over the SVTA is we're cataloging, going through and identifying key technologies from groups like the IETF. And we plan on submitting a draft into MOPS, cataloging what professional groups are using in terms of IETF technologies, what really key ones, because obviously you use a lot of things right at the very bottom. DNS. DNS is used by everything, obviously. But clearly, we have ingest stuff going on. We have WebRTC, big thing in this world. HLS, huge. And all the caching work. In fact, the CDNI caching being done here at the IETF is built upon, and I have a few slides about that, but it's built upon over at the SVTA into a thing called open caching, which is then being used in production in environments in the real world. So it's a great connection point. Next slide, please. Oh, but I see I got a typo there. I should have RFC 9000 for quick, not 900. I will fix that.
That's impressive.
Prescient.
This is a horrible picture, but it's a great picture at the same time. And if you go to that link, you can actually see the full picture in all its glory. What this does is this is a mapping of where open caching from SVTA makes interconnections with CDNI from the IETF and builds it actually into a production environment. So you can sort of see where the two pieces all connect together, and it makes it all very relevant for us here at the IETF and what we're working on. And that is a horrible picture, I admit it. I'm going to try to get them to make a better picture for next time we do this so we can sort of illustrate it and you can actually read it. So my apologies. Next slide, please. We have updated the open caching configuration interface specification. Again, this builds upon CDNI. There's version 1.1 just got released over at the SVTA, sorry. I'm still stuck without that T. I need to learn to stick that T in always. But this covers, the interfaces for controlling these environments that are deploying CDNI built upon the open caching framework from the SVTA. Next slide, please. RC9000. So there's a POC going on over at the SVTA, which is attempting to take Quick, because for a lot of streamers, Quick, everybody knows, next new thing, really cool technology. Production environments, very hesitant at times to pick up brand new technology and deploy it at scale. This is scary. And when we talked to the people who were doing these things, we said, well, what's your key problem? And they identified, well, I know I want to play with it. I know I want to test it, but I don't necessarily know how to do that. There's too many options. When I say, give me a quick server, there's a lot of quick server implementations out there. How do I test that? I don't know. I've got a lot of guys that are have expertise in TCP delivery, quick delivery, not so much. What do I even have to ask the questions of? So what we've taken on is doing a POC, but it's sort of a meta POC. In addition to ultimately measuring, quick delivery versus HTTP2 delivery, we're also documenting how do you build that test environment so that people who want to play with the quick technology for streaming delivery have a framework that they can take, and then they, in their own environments, can build it, test it, and run it. And this involves things like metrics. How do you hook into players on the player side and collect data from them? How do you monitor on the network? And how do you ask the questions? And what questions should you even be asking when you want to evaluate and understand Quick better? Next slide, please. And in fact, one of the exercises we're doing isn't at the very end of that POC to produce a final report with a lot of glossy slides. What we're doing is along the way, we are documenting the thought process that's going into the Quick POC. So one of the things we've already produced, we've produced a tech brief that talks about Quick overall for the streaming environment. Next slide, please. And I fixed the slide, I think it was there. And we also have produced a document which talks about the testing environment and the criteria and how we're going to go about doing it. It documents the lab environments. We have a phase 1 lab environment, a phase 2 lab environment, and it talks about SD, HD, 4K, VR content, and the various congestion control algorithms we're going to play with as part of the test framework. And so this idea here is that you can not just see the results of the test, but even before we run the tests, you can weigh in on what tests are going down and why would you even do that particular test, and ask the question, are there tests that we're missing that are relevant to the professional media environment? And that's available at the link down below. Next slide, please. So there's a few of us, actually, the participants here in the SVTA, but so Sanjay over here is one of the chairs over there, and there's his email address if you want to find out more information. I'll point out Ali as well, a chair over at a working group on players, and I chair the networking transport group. So if you're interested in any of the work we're doing, if you've got comments, again, we release it publicly, so you can go take a look. You don't have to be a member to read it. Have a look, come find one of us or drop us an email and ask us questions. We're happy to answer them. And with that, I'll take any questions that people have at the mic line.
And again, I'll encourage people to use the MediaCo mic line. One thing that I'd like to sort of reiterate while waiting to see if there are questions or thoughts is one of the reasons why we're particularly keen to have these ongoing updates from the SVTA is the fact that that's the alliance of industry players who are deploying this stuff and using it at scale. So, I mean, I think that it's valuable to see what kinds of experiences and expertise is available there, and not just sort of this is not academic deployments of technologies, but rather real world deployments at scale. So opportunities to ask questions and see what's going on in terms of the use of our technologies in that context.
And we've also the outreach between the two groups has resulted in a whole pile of people that are SVTA people who didn't previously come to IETF meetings. They're now coming to IETF meetings and getting engaged in the working groups here, which is really awesome. That's something I've championed for a long time, to get more media people into the room here, and we're getting them, and I'm really happy. Success is always good. So
Sam,
I think there was.
Yep, go ahead.
Sam Hurst, BBC R&D. Just to clarify, when you say over quick, do you mean stuff over HTTP3 or more broadly everything over quick?
No, it's already GTP3.
Okay, so it's
The frameworks were, yeah, we're not trying to get into the weeds yet with it. It's really just using it as a transport pipe.
Okay, right. Thanks very much.
But maybe down the road we'll play with, we'll get in and play with some really cool stuff. But
Yeah.
baby steps.
Yeah, yeah. There's the mock working group as well, which might be of interest there. I can't remember exactly which day that meeting's on.
Okay, if there's no other questions, I'll give up the mic.
Great. Thank you very much, Glenn. All right. So next we have Luis Contreras talking about, yes, thank you.
Hello, everybody. So I will present now a follow-up of the one project that we have in Telefonica. The idea is to deploy Alto for exposing the network topology that could be consumed by the Telefonica CDN. So this is an update from last IETF. So next, please. So the rationale for the work, as a reminder, well, the idea is to optimize the delivery of the traffic, right? So nowadays, the CDN in Telefonica is consuming the topology, but is uploaded manually. So this is, apart from being prone to errors and so, the point is that they are working with a semi-static view of the topology. Even though the topology is uploaded time to time, there is some, in between the gaps, let's say, of this upload, there are changes in the topology, and these changes are missed, are lost. So the idea is to have an automated way of populating the topology in such a way that Telefonica CDN could have a timely view of the topology in every moment, right? So taking the best decisions, not only thinking on the capabilities of the cache nodes, but also on the transport circumstances, the transport situation. So this project was presented in last IETF, so I will commend the progress on that. So next, please. Yeah, also as a reminder, we are playing essentially with two concepts, the network map and the cost map. In the network map, essentially, we identify or we associate in different PIDs the prefixes of the, let's say, the endpoints of the map. In this case, the endpoints will be the prefixes of the end users on one side, so the ones that are requesting the content, and on the other side, the endpoints will be the CDNs, the caches itself. So we will have the idea is to have a number of PIDs considering all these kind of endpoints, right? And then we will have the cost map. The cost map essentially shows the relationship in terms of some metrics between those PIDs. In this case, the metric that we are using by now is the number of hops. The idea is to improve and to enrich all these metrics in the future, adding performance capabilities like latency and so. So important to say, the network map is essentially retrieved through BGP. So the idea is that Alto contains a BGP speaker. The BGP speaker is connected to route reflectors in the network for collecting this information from the users. So BGP session in that point. And the cost map is retrieved by leveraging on BGP-LS. So BGP-LS provide us the view of the topology, how the different nodes are interconnected in the network. So having a view of the number of hops, or some other capabilities that could be exposed by BGP-LS. Next, please. So the process follows so far. We started with some toy environment in the lab. Then we moved to the pre-production lab. And then finally, we have run a pilot in a live network 2 weeks ago, 1 week ago. So the work is yet ongoing in terms of processing the information. And this is what I will present to you. So what we did between IETF114 and IETF115 was essentially to put the Alto into the production network, so fitting all the security stuff, the server installation, the definition of the flows, how to connect with route reflectors, and so on so far. So next, please. There was, at the time of running the project, there was an initial constraint, an initial restriction. So this kind of level shows you a basic topology, basic hierarchy that we have in Telefonica network. So we have more or less 1 to 5 levels, in some cases 6, depends on the size of the country. Being the level 1 interconnection, being the lower part, the cell side router. So between the backbone level, the mesh of the routers connecting or moving the traffic in the national footprint and connected with the different regions, we have some issue with one of the vendors, one of the router vendors. The operating system that we have didn't support or had problems for supporting BGPLS for OSPF. So we are trying to fix that. This was an initial constraint, so we know in advance that we will not collect, or we will not be able to collect in this point, or to retrieve in this point, the complete topology, but at least we have a region that is completely, we have all the software there. So at least this would be, let's say, the POC will be focused on this region by now. Next, please. So after realizing the POC, the pilot, so in the preliminary analysis that we are running, we have some good news and not so good news. So I will present first the good news. So we are retrieving a good amount of summarized IP address ranges. So these are ranges that are used for fixed, mobile, and enterprise. This is more or less as expected. Also, some of the IP ranges are external. This is and the external ones that we are collecting and are those for the national interconnection. The point is that in Telefónica, the international interconnection is run by a carrier, a tier 1 carrier, also from the Telefónica group. So what we are collecting here is only the national interconnections that are being run by this operation in Telefónica. So this is good because in the Telefónica CDN is serving also traffic to external customers. So it's good to have a view of those that are not from Telefónica side if we have in the national interconnection or in the international interconnection. It's certainly true that this could be obtained by other means, but here we could have an automatized way of collecting and let's say retrieving the information that those customers are reached by certain nodes that are serving the national interconnection. So we could optimize the traffic also for those external customers that are not part of Telefónica. The available information in the cost map is correctly retrieved as well and reflects the defined IGP metrics. So that is working fine. So we are not taking only the number of hops, but also we are taking the proper IG metric defined on those links between the nodes. And from the perspective of the Alto server itself, the load of the service is not significant. So we are retrieving all the topology, even though we cannot relate because we have that gap for the BGPLS, the OSPF that I mentioned before. We cannot stitch, let's say, all the nodes, but we are retrieving the information from all the nodes and the load of the server is not high. So it seems to be sufficiently, scalable. So next, please. In this slide, I show you just an example of the network map retrieved, the real network map and the real cost map. I put some asterisk on the PIDs just to, let's say, don't disclose, let's say, the real information of the network, but you can see the IP addresses from Telefónica side, and also you can see in the cost map, the actual IGP metrics between different PIDs. So this is being collected properly at this point in time. So next, please. The not so good news, or the news that, the points that we need to keep working on is that we don't have information for some POPs. 4% of the POPs, we are not receiving information, so we need to analyze what are the particularities of these POPs, why these POPs are not populating the information. Also, some of the IP ranges seems not to be retrieved, so we need to check if we have the proper BGP sessions established. So probably it could be the case that we need to connect to some additional route reflector. So this is also under study. And probably a more complex problem is this, the third one, that we only have 27 PIDs, both in the network map and the cost map. This could be the case of the OSPF issue for the BGPLS information that I mentioned before, but we need further analyze this to verify that this is the point. And also the latest one, the PIDs for the CDN nodes, the caches are not yet captured. So probably is also a matter of connecting to a new route reflector. So this is as well under study. So next, please. So as next steps for the pilot itself, to understand, the first point will be how to understand, understand how to consume the Alto information, so how often. So we need now to enter into the operability of the Alto information. So to define the frequency of retrieving the topology, analyzing the topology, and uploading the topology automatically. Also, we need to continue analyzing the information received to understand the dynamics in a production network. So how the changes are reflected, how we can be sure that we don't lose, let's say, any kind of change in the network. Also, we need to debug the issues that could be found during the process. So this is a new process, and we don't have an operational experience on that. And then we need to wait for sure until the resolution of the operating system of this router vendor to be ready for having the possibility of stitching all the areas, all the PIDs, and complete, let's say, the map of all the network. For the Alto-based solution itself, the point now is to enter into the productification of Alto. So make some developments on Alto and create a component that could run smoothly in an operational network. So all the security concerns, the logins, all this kind of stuff, the logs and so. And then also to work on the loading automatically the topology into the logic of the Telefonica CDN. So by now we can retrieve the topology, but it's just pending to let's say, to integrate that with the logic of the Telefonica CDN in such a way that could be essentially automatically done. And for the Alto and MOPS working group, the intention is to document the pilot. So I'm not sure if this could be also interesting for MOPS. Second step is to identify gaps, issues, and improvements in the solution. For instance, we are now seeing that probably we need to do something into the security part. So somehow obfuscate the PIDs and so if we are exposing this to third parties. So that would be a matter to, let's say, not reveal sensible information. And then, well, and the next step, final step for sure is to provide another update if possible in the next IETF and hopefully with all the solves issue. Let's see if we are able to do that. And I think that was the latest one. So thank you.
Thank you very much. So any questions from remote or local?
Frédéric Orange. Do you plan to work with other telecom operators or any?
You mean to work in terms of sharing the development
in terms of
or exposing?
Yes, for instance, or interconnecting some Alto maps or
well, there are no plans by now because this is let's say internal project for the CDN. But once we have the Alto in place, we could consider to expose that topology to third parties for sure. But there is no a plan for that right now. Some capabilities should be incorporated. They probably to filter some parts of the topology and so. So this, I mean, as it is now, probably would not be the way of sharing with other operators. Further work could be required for filtering things and so.
Thank you. And I'll again encourage people to use the Meet Echo queue for asking questions.
Otherwise, they show up as participants.
Yes, as our note taker says, otherwise they show up as participants. So you lose your fame and glory. All right.
Okay, thank you.
Thank you very much. Okay, then moving right along, we have a remote presentation now. I believe he's remote anyway. Lenny, are you ready to go?
Yes, I am.
Great.
So should I request to drive the slides or just tell you to advance them? And
if you want to share, I'll stop sharing, Lenny. Just use the sharing tool. There you go. And okay, looks good.
All right. Can you hear me okay? I'm sorry, Kyle, is my audio good? Can you hear me?
Everything sounds good over here.
Great. All right, thank you. So we'd like to present today our draft on TreeDN, which is tree-based CDNs, which is an architecture optimized for live streaming to mass audiences. The problem we're trying to solve with TreeDN is, are we at a unique perhaps inflection point for the internet, with live streaming audiences kind of exploding in size? Combine that with increasing size bit rates, something that was talked about in previous talks today. Are we at an inflection point for the resources consumed by live streaming on the network? One recent perfect example is, for those not familiar, NFL Thursday Night Football, which is American football, is in the last 2 months, for the first time ever, is being streamed exclusively over the internet. Amazon Prime announced that the first game, which was in mid-September, had, I believe, over 11 million streams for that event. So the question is, for those not familiar with American football, it's kind of the closest thing to a national religion in the U.S. So with events like this occurring and becoming more common across the internet, like I said, are we at an inflection point? If not now, will we ever be? And if the answer to either of those questions is yes, the question is, what should we do? One thing to keep in mind is live streaming has a unique set of requirement or characteristics that are different from, say, on-demand streaming. There are some folks have said, hey, what's the difference between live streaming versus people just watching on-demand movies on Netflix? If people are going to be watching, there's a fair amount of saturation, and people are, on a given evening, they're probably going to be watching something. What's the difference whether it's a live stream of a game versus a movie? And when it comes to live streaming, particularly of say sporting events, it's the most obvious use case. There's an expectation of lower latency. For example, if you have if you're watching a movie, you can live with a minute or two play out buffer. The movie was made perhaps years ago. On the other hand, if it's a sporting event, much longer than, say, the 10 seconds that traditional broadcast television has had, you run the risk that you could get a text message from your friend saying, man, what an incredible, game-winning score, a minute or so before it actually happens. Or you hear people cheering next door or at a bar before, a minute before you see what happens. And then, for use cases on things like in-game micro betting, the latency requirements are even tighter. The other thing is join rates and traffic rates are vastly different between on-demand and live streaming. If you look at the typical traffic streams on a service provider, what you'll see is kind of a very smooth, predictable growth rate. There's, we've all seen kind of those diurnal patterns of, it starts out at about 9 a.m., rises till about 5, and then drops, and then about 8 p.m. up till about midnight. You see a much higher spike, and that corresponds to people watching stuff, streaming content over the internet. It's significant but predictable. On the other hand, if for sporting events, it can resemble more of like a step function, as everybody tunes in and tries to join a stream, right at game time. How do we solve it, or how do we address this in terms of network-based replication? this is a much more efficient way of delivering this content. And specifically multicast has been, this is what multicast is out there for. And it has been fairly successful in some use cases. It's absolutely vital in financial networks. For video distribution networks, it's commonly used, as well as VPN service providers and some enterprises. It's a must-have solution, and it is used in these places. However, on the internet, in terms of internet multicast, not so much. It hasn't had the best story for success over the last 2+ decades. So it's worth asking, what went wrong when it comes to internet multicast, and is this a viable option for this type of content? There have been over the years, the best way to describe the issues with internet multicast has been kind of like 3 main problems with internet multicast. One is the all or nothing problem, and that is for multicast to work, you need every single layer 3 hop between the source and destination to be multicast enabled. Needs to be running some type of multicast routing protocol. And it turns out having every single interface on every single router and firewall on the internet running a complex set of protocols is a pretty high bar. And it's proven to be really, really difficult to get everyone to do something like this. I think V6 has a similar problem. Anything that requires, that kind of level of change on the internet ubiquitously is going to struggle for traction and deployment. The second problem has been, anybody who's familiar with multicast is probably aware of the challenges and the complexities of deploying and operating a multicast network. Operators have long complained that the protocols are really complex, and it's too difficult to deploy, operate, troubleshoot. They've complained for years that just multicast is just too complex. And then, of course, there's the chicken and egg problem, which is, there's no multicast audience because there's no multicast content, and there's no multicast content because there's no multicast audience. So the good news is there have been recent developments in network replication technologies that are available today to address these problems. So, it's not your grandfather's internet multicast solutions today. We now have solutions that address these problems, and I'll kind of go through those. So what is TreeDN? Tree-based CDNs. It leverages advances in and developments in native technologies as well as overlay concepts to deliver a service to end users, even where parts of the network don't support multicast. So if we kind of divide the problem up to, there's the native component of the network, as well as the overlay. Let's talk about the native part. What TreeDN prescribes is on the native part of the network. That is the part of the network that supports IP multicast natively, to use SSM, source-specific multicast. It turns out the complexity that folks have complained about with multicast, it's not that multicast is too complex, it's that ASM is too complex, which is any source multicast, which is the traditional model for multicast. SSM is source-specific multicast, and it vastly simplifies the deployment of multicast. With SSM, you eliminate a lot of the complexities and headaches of multicast, things like rendezvous points and MSDP and shared trees, PIM register messages, register NCAP, DCAP, tree switchover, data-driven state events. All of those things, which comprise probably, more than 90% of the complexity of multicast, get eliminated in SSM. SSM can be delivered, it's most often delivered by PIM SSM, but could use any protocol, any multicast routing protocol, or delivery mechanism, data plane delivery mechanism. The point is, if you just use SSM, you can address the most common use cases and eliminate a lot of the complexity of multicast deployment. The second key component of TreeDN is overlays, and automatic multicast tunneling, AMT, which is described in RFC 7450, is a technology that dynamically builds tunnels from end hosts, you know, a laptop, smartphone, iPad, whatever, and it enables the tunneling from end devices to the border of the multicast enabled network. So it allows users on unicast only networks, unicast only parts of the network, to tunnel dynamically to the edge of the multicast network and receive content. So this enables any and everyone who is on the internet with AMT is able to receive multicast content, even if they are not on a multicast enabled network. So this solves the all or nothing problem, that fundamental, you know, probably the biggest of the three by far problem of all or nothing. Also solves the chicken and egg problem, because with AMT, potentially every single host on the internet is a potential audience member. AMT is the most common, has some really nice benefits because it's a dynamically built tunnel. It can be integrated into the application or in the host stack. But any other overlay networking technology could also be used. Something like Lisp, you know, is another overlay technology that could also be leveraged for this component of the network. The key thing is TreeDN provides, you know, a significant benefit that previously was not available with multicast, which is incremental deployment. For those parts of the network that are multicast enabled, they enjoy the benefits of multicast. And for the rest of the network that is unicast only, we simply tunnel over those parts of the network. So end users receive the service regardless of what the topology looks like. You know, significantly, end users are not dependent on their last mile provider to support multicast in order for them to receive the content. So here's kind of a 30,000-foot view of what TreeDN looks like, and you know, those familiar with IP multicast technologies will notice that there's nothing groundbreaking or really new from a protocol standpoint. It's really the synthesis of existing tools and existing protocols to define an architecture and describe an architecture that operators can leverage and service providers can use to deliver new services for customers and end users. So we can see here you have the big I internet, and within that a smaller subset of the network that is multicast enabled. Traditionally, we've called this the M bone, which is the multicast enabled part of the internet. But you can imagine you have a TreeDN provider that the green part of that green cloud is a native multicast enabled network. You have a content provider pushing out multicast content, and that traffic is delivered natively within the green part of the network. And if you have receivers who are off-net, who are on unicast only networks, we use AMT to tunnel and deliver that traffic to them. That's kind of the high-level view of the whole internet and where TreeDN fits within that ecosystem. Kind of drilling down into, you know, what does, you know, what would the TreeDN part look like? Let's compare it, a TreeDN to a CDN without multicast. There's different models for CDNs, but a common one is you have an origin, a source with content that kind of pushes it out to CDN boxes pushes it to 1, and they kind of distribute it. And those CDN boxes that are deployed throughout the network handle local receivers. It's much more scalable than unicast, obviously, and has the nice benefit of not requiring, it just works over the internet. It doesn't require, a set of, it doesn't require multicast protocols to make it work. So that's why it's been popular. That said, with TreeDN, to compare with CDNs without multicast, we can rename those CDN boxes. We'll call them AMT relays. Push them out to the border of the network, and they deliver traffic. Notice that the multicast tree gets delivered natively from the source to those AMT receivers. Those AMT relays who handle remote local receivers. Some of the differences. One, like I said, it's pushes the replication points to the border of the multicast enabled network. It also delivers only to relays that have interested local receivers. If there are no interested receivers in an area, those relays will not participate in the tree. And the key difference, the key value is if those AMT relays are deployed on existing network infrastructure, it's essentially a CDN on a chip. There are router platforms out there that support AMT tunneling natively. And what that means is if you have these devices in your network at the borders of your network, say at peering points or at edge routers, you can offer this service at essentially zero cost, at only the cost of configuring a few lines of config on your routers. So it's essentially zero capex, and you can argue, zero opex, because you're not, typically CDN boxes have been these, a stack of x86 boxes that are sitting in a network that need to be racked and powered and plugged into revenue generating ports on routers and the network infrastructure. We eliminate that when it's built directly in and available in the existing infrastructure. So you get the benefits without having to deploy any new boxes. So that's the key benefit of using CDNs with multicast or TreeDNs as opposed to without. So in terms of the benefits of TreeDN, one, you get the more efficient utilization of the network and resources by using the latest and greatest capabilities in network-based replication. We're not just talking about scaling to support existing content, but really it also, more importantly, scales to make new content viable and available. So think about live streaming of AR to mass audiences. We saw some of those numbers discussed in an earlier talk this morning. What if you wanted to live stream in AR, the experience of sitting courtside at a front row center court at a basketball game or a soccer football game? What it's like to sit in the stadium and you look left and right and you see the crowd and you see the game as if you're there. And what if you wanted to deliver those streams live to mass audiences of thousands, tens of thousands, perhaps millions? Could the internet do that today? If so, it'd be really, really expensive. With TreeDN, this is something that can be trivially done because the network need only, a given link need only be able to support enough bandwidth to handle a single stream. It enables service providers and operators to offer new services, replication as a service. Send us your content, we'll replicate it, and we'll deliver that to end users. Essentially, this is what CDNs have always been. But what's key here is it allows operators to offer this service at potentially zero cost to deliver the service if existing infrastructure already supports AMT. It's also an open standards-based architecture that's that's leveraging widely available protocols, as opposed to some CDN technologies that are kind of proprietary or specific to certain operators. And it also requires far less coordination between the content provider and the CDN. Essentially, with TreeDN, the CDN is just forwarding packets. There's no need for storage or data protection or key management, things like that. Just pushing out packets. The other nice part of this technology is it is a democratizing and it's a decentralized architecture, which essentially makes it exceedingly inexpensive for sources to send high data rate streams to an arbitrarily large audience. Most of the technologies and solutions available today on the internet are dependent on a small handful of companies. And is it healthy for the internet and society that the only way to distribute live stream content to large audiences is the only really viable way is through a handful of companies to distribute that content. This is a decentralized and democratizing technology for content distribution. In terms of use cases and applicability, I focused on live streaming of video because that's kind of the sexiest and most interesting use case. But really, it's applicable for any traffic that needs to go to multiple destinations. So live streaming isn't the obvious and sexiest use cases. Typically multimedia, audio, video, specifically AR. Could also be telemetry data from things like imagine weather satellites that need to push out real-time telemetry data to research institutions. That's one use case. But there's also large file software updates, things like OS upgrades. Those are things that can really crush a network when you have an OS upgrade that needs to go out to say tens of hundreds of millions of devices, say the latest iOS upgrade. So it's really any multi-destination traffic. So kind of to summarize, what is TreeDN? It's really about kind of there's these crossing of supply and demand curves when it comes to live streaming on the internet. On the demand side, it's really that combination of exploding audience sizes combined with increasing bit rates to generate large amounts of demand on the internet for live streaming and the potential resource consumption implications on the network. And on the supply side, for those who kind of tuned out and said 15 years ago and said multicast isn't viable, let's not waste our time on this. There have been developments and evolution in how multicast can replicate across the internet and address the issues that plagued internet multicast in previous decades. So it is now easier to deploy and more available and useful than ever. So it's really kind of the synthesis of existing tools to address a very recent phenomena where live streaming is consuming significant amounts of resources on the network. And that's what TreeDN is. It describes a CDN model to address this type of content that is putting increasing strain on the network. Not only for the content of today, but also enables new content from potentially new sources for tomorrow. In terms of next step, we'll be presenting this at MBOND as well, but we're looking for working group adoption. Is this something that, I've looked at MOPS, the charter for MOPS, and I think we'd be open to MOPS or MBOND, but to me, it looks like MOPS, based on the charter, seems like the more appropriate place. There's a lot more expertise in the CDN area. So we'd love to see if MOPS is interested in adopting this work. With that, I'd be happy to take any questions.
Thank you. And Kyle is first in the queue.
Thank you, Leslie. So I'm speaking as with hats off, not as chair here. I have a couple of points. So I read the draft when you initially made the request to present at MOPS, and I thought it was really interesting. The presentation here has answered a bunch of the questions that I had after reading the draft, but I still have some issues, and I don't know if we want to go into all of these at the moment, but I can maybe outline what I was thinking. So the issue of, or the benefit that you say about it democratizing content distribution is, I take that as like that's a good point. I'm not sure, like that addresses democratization of availability of the sort of replication function, the fan out function. It doesn't address the democratization of content, right? I mean, there are rights holders that have access to that have exclusive access to, say, sporting events, and that's not gonna go away. You're not gonna be able to legally broadcast some soccer game, right, that you don't have rights to broadcast. I mean, you might be able to do it technically, but somebody will shut it down. So there's that issue. But you also, I mean, you're introducing a novel attack surface when you have replication as a service, and so not having any controls over that seems like it at least requires a significant amount of thought to figure out how to avoid problems with that, right? The only other thing that I was thinking of as I'm not trying to throw cold water on this. I'm just trying to bring up a bunch of things that I thought of when I was reading the draft and listening to your presentation, is related to the content rights issue is, you say, well, there's no key management. Well, that's not really true. You're just kind of moving key management to another layer, because the CDNs are required to only make the content available to people who are, say, paying subscribers in that case. And there are related issues around privacy that you're going to run into when you try to integrate this into say web protocols. And this is something that Jake and I were spent a lot of time trying to figure out how to address in a way that would not set off everyone that who over the past 10 years have put a ton of time and effort into thinking about what are the consequences of outside observers being able to know what content you're consuming, and how do you kind of fit that into the web security model. And it's not, there are a lot of subtleties there, and I don't think we've even kind of teased them all out yet, but it's something that I'm happy to help work on to push this work forward. I just think that there are a bunch of issues that remain unresolved that go well beyond the technology. That's essentially the broad point I'm trying to make.
Sure. So let me try to take all three of those, and I wrote them down. It's kind of early, and I'm struggling to remain cogent. So hopefully I
can throw them in the chat too.
Yeah, and I think maybe what we want to do is just address them at a very high level, and then I think they're
Sure.
pointers to questions that would need to get addressed.
Gotcha. In terms of content rights, yes, absolutely. I think that goes without saying. You can't legally broadcast something on the internet, content on the internet, unless you have the rights to do so, or rather, the other way around. You can't legally broadcast something if you don't, if if someone else has rights to that. But from a democratizing technology, think all the content in the world that doesn't have, that isn't restricted by content rights. So imagine nature cams. Imagine flying a drone around, or nature cams, or broadcasting the sporting events or other kinds of events that don't have explicit rights. I think it goes without saying that democratizing the technology that democratizes something does so modulo the rights to actually deliver that content, or to actually broadcast that content. In terms of attack surface, multicast has a different attack surface than unicast. I wouldn't say that it's more risky or less risky. I think it's, in some cases it is more. It just has different risks. So for example, things like spoofing, because multicast has RPF built into it naturally, you can eliminate lots of spoofing attacks on the data plane. So it's in some ways more resistant to certain data plane attacks. However, it is more vulnerable to, say, control plane attacks, because you have users generating control traffic on the network in ways that you don't necessarily have with unicast. So I don't know that it's more insecure or less insecure. It's just, it has a different attack surface. And there's lots and lots of work over the years that kind of describes, how to harden a deployment to address some of those security issues. And the last thing about the key management stuff that you mentioned, I guess what I meant, what is meant there is that you still have key management issues, but it goes on between the content provider and the end user. So you can do things like encryption, and you don't necessarily have to the intervening players between, say, the CDN provider don't have to participate in that scheme. But it's certainly, for example, if you want to source a stream and encrypt it, and you need to distribute those decryption keys, but you don't necessarily, again, need to coordinate with your CDN to do that. So that's kind of the CDN is just pushing packets. In terms of, again, I don't think that's unique to multicast. I think any broadcast technology where traffic can be visible to multiple end hosts that aren't necessarily entitled to receive that content, that's an issue. So, a good example is Wi-Fi. Everybody on a Wi-Fi network can see those packets, but you can't necessarily make sense of them unless you have the ability to decrypt them. Hopefully that answers your questions, Kyle, or addresses those concerns. Sorry.
Right. I mean, yeah, and I'm happy to talk more about this offline. Having put a bunch of thought into this, but
Sure.
But yeah, I mean, yes. Thank you.
Okay, thanks.
Yeah.
Eric.
So Eric, getting the responsibility for MOPS. So regarding your last line on this slide, it looks for me that document, I still have to read it, to be honest. It's more like best common practice or informational about how you can stitch existing technologies together. So MOPS would be the perfect working group for this. Right, we are not allowed to do any kind of protocol work. So if you need to do extension to AMT or whatever, I'm bound. Right, but you're more than welcome here. And I hope that Kyle will write his questions on the mailing list, and we got a reviewer, at least one. Now, as an individual contributor, I just wonder, and I see your co-authors from Verizon, so do you intend to run some proof of concept to get the scalability issue fixed, for instance, or identified?
So This is actually being, in use and deployed today across the internet. There are providers that, I welcome you to join us in MBOND, and there's going to be an operator who will talk about how they're essentially doing this in their network on Wednesday morning. So yes, this is, and there has been a TreeDN network that's been up and running for the last few years. It's connected to Internet 2 and Giant nodes, and has been delivering content using this architecture for the last few years. So yeah, it's not just Verizon, but it's been deployed by a number of operators on the internet. And that's not to say, by the way, I'm not, I can't speak for my co-author in terms of what his company is doing in terms of whether they are or aren't delivering this service, but it is being used on the internet today. So this is really, as you said, Eric, there are no new protocols here. If it was, actually, that would probably belong in PIM. MBOND isn't allowed to work on protocols either. But there's no new protocols. It's more about, using existing protocols to deliver a service, and here's how. But
okay, thank you.
Thank you.
Han Shi from Huawei. I wonder how this multicast interact with the transport layer protocol. For example, if you are using TCP, where does TCP end? End in the relay or end user?
It definitely does not use TCP because it's multicast doesn't support TCP, so it's typically UDP. We're kind of agnostic to the transport as long as it's an IP multicast packet. We'll put another way, any non-TCP traffic that is multicastable can utilize this technology. It's kind of agnostic to the to what transport protocols are used.
So the relay only translate between the multicast and the unicast. It doesn't aware of any upper layer protocol, right?
Say that last part. It's not aware of what.
Upper layer protocol. Any RDP, UDP, or media transport
Correct.
protocol. Okay.
Correct. The relay is just it's just tunneling. It takes a multicast packet in and sends it through a UDP unicast tunnel, and the end receiver receives that multicast packet. So we're just pushing packets. We're not participating in the transport.
All right, thank you. So I think at this point we are looking at the last bullet on a slide and looking to see if there is interest in the parameters that Eric and Lenny discussed, that this is focused on more or less best current practices and stitching together existing technologies. I think what we'd like to do is take assuming Lenny, you're still interested in seeing if MOPS is willing to take it as a working group item. I think we should do a hum here and then take it to the mailing list to see if there is general interest. So I'm not seeing any strong objections and some mild nods. All right, so just a simple hum, or we should use the Meet Echo. Yep, all right, so, but the question is simple, whether or not the answering it is. Do people at this meeting feel that MOPS should take up this work as a working group item? Yes or no? Yeah. And again, this is more or less to get a sense of things. We will confirm on the mailing list. this time limited or should we call it? All right, thank you for the input. It sounds like there is a fair bit of support for adopting this as a working group item. I wouldn't mind hearing from the people who have not raised their hands what their particular objections are, if they're willing to share.
But no pressure.
All right, well, it sounds overall like there is interest in taking this on. So we'll, again, follow up on the mailing list and follow up with you, Lenny, offline and at a point where there might be sunshine where you are, to see about moving this forward. Anything else we should talk about this topic today? All right, thank you very much.
Thank you.
All right, I believe that takes us to the end of our scheduled agenda. Are there any other points of business? Going once? Going twice? All right. Thank you all for coming this Monday morning, and have a great rest of week.
No worries. I was just like, hey, Lars? So you're not Lars. I thought Lars was here. My bad. I saw you from the back. Sorry? Everything goes? Yeah. Well, I mean, I think everybody has doubts on what we can. Yeah, the next thing